Thanks for coming. I'm Chad Foley. I work in the City of Raleigh IT department. This is my colleague Peter Sherman. We share a lot of responsibilities and duties around different GIS asset management things, but I want to give a little disclaimer that what we're going to cover here today is not really something we do day to day. This is, kind of in our spare time when we have a chance. We would like to do it full time, but it's really just a small part of our daily role, if any. So when we sneak away, we work on this project. It's a lot of fun. I just kind of wanted to start out with just acknowledging that I think we're living in a really interesting time right now. A lot of, you hear a lot of talk about AI and IoT, and a lot of this technology has been around for a while. But what's really interesting to me is that it's now accessible to guys like Peter and myself. These AI packages are, now bundled in JavaScript or Python libraries, and guys like us who, I don't know anything about AI, but I can use it, which is incredibly powerful. So we'll do a little talk, a little history behind this project, and then we'll attempt a live demo, which will be fun. And feel free to ask any questions, and we should have enough time at the end. But I'm going to hand it over to Peter, and we'll kind of give a little history.
All right. So on the agenda, the why of why we're doing this, challenges that we faced along the way, a solution we came up with, a demo, moving forward. So for the why, it all started with bees. One of our coworkers is a beekeeper, and he was, as many beekeepers did this past winter, he was losing bees in his beehives, and he was wondering how could he count how many are entering and leaving the hive on a daily basis. So he thought, that'd be a really cool thing to do with video analytics, because obviously he's not going to sit out there and count them. And then at some point along the way, we discussed this with someone from the Department of Transportation we work with pretty often. And he said, yeah, that'd be great to use as well for when we count cars. Currently, they have a GoPro. Go to the next one. They have a GoPro that they put up on a signal pole or a light pole, anywhere it will go. And then they have that out there for an hour, record the video, bring it back into the office, and take the video off, and then send it to a contractor. And they spend a lot of money on a yearly basis having contractors count the cars at peak hours. So this
I might interject a little. I think it's like up near $100,000 a year, and it wasn't very long ago that they were videotaping the intersections on like VHS, hiring students as temps to literally sit in a room and count the cars and watch the video. And before that, they had guys sitting out on the intersection with a clipboard, making marks. So even the GoPro method's fairly new, but it's a pretty expensive solution.
Yeah. So that's what it looks like right there, a GoPro mounted on a pole. And this is separate from their other traffic cameras. They have about 100 traffic cameras throughout the city, but for reasons I'll get into with the challenges. Go to the next one. So those traffic cameras, they don't store the video due to subpoenas. On about a weekly basis, they'll get calls from lawyers wanting the recording of that video for accidents that happen at those intersections. So they made the business decision that they're not recording the video so that they don't have to provide it. And also so they don't have to store it. So it's just used as like a way of checking traffic at a single point in time, checking that stream, which you can also analyze streams with TensorFlow. Some other challenges with this are what kind of hardware are you going to use to go take the videos? I mean, you can use a GoPro and then go back and analyze the video. We purchased a Raspberry Pi, so we have that, and you can get a video module for that, and then you could go mount that outside. You just would want a good case for that to protect it from the elements. And also communication. As Chad mentioned, this is kind of a dream project that we work on in our small amount of free time. We can't all be like Google with their 20% time where they get to work on whatever they want. So it's a little bit hard to get traction because it's a low priority with other departments. And a really tough challenge was the environment set up for TensorFlow on Windows, including on the Windows or the Linux subsystem for Windows. Even using that, it's fairly difficult to get set up because there are a lot of outdated guides out there, and it's moving so
the minute
fast.
somebody posts a tutorial, it's outdated the next day.
Yeah.
And you get into dependency hell.
Yeah. And there are cloud solutions for this, like Microsoft Azure or Amazon AWS. They have their own like machine learning APIs, I think, that you can call to do some of this stuff. I'm not sure how much that would cost, but if you wanted to have a whole lot of videos and send them up, video files are large, and then processing them would take a lot of compute power. So it probably gets pretty expensive. So what we came up with as kind of a pilot was an in-house static solution that we can do right on our laptops and with a Raspberry Pi or another camera sensor. So we purchased the Raspberry Pi hardware, and yeah, we're running it on a local environment on our laptops. If you have a desktop computer with a graphics card or GPU, that'd be a lot better. But just as a proof of concept thing, it's okay running it with your processor if it's a short video. If it's a long one, you might want to start it at night and come back the next morning. So yeah, that's a picture of our Pi there on the right. We went with the Raspberry Pi 3 and the camera module, which is about $25 for that module that attaches to it. There are other non-Pi brand solutions that are a little bit cheaper. And even just with that, that's a fairly cheap camera when you compare it to like a GoPro or something. That records 1080p at 30 frames per second. So that's pretty good. And yeah, it's a very low-cost solution. So you can actually get by with the Raspberry Pi Zero W instead if you wanted to, because that will record video fine. You just have less ports on that and less USB ports, but that's only $10 as compared to the Pi 3 for $35. You need at least a 1 amp power supply, which is roughly $10. A power cord you probably already have. A camera is $15 to $25, as I said, and a 1 amp battery backup. So if you want to put it outside, you need a source of power. If that doesn't already exist on the pole in a way that you can use, you can just use a simple battery backup you would use for your phone, or like if you were here at the conference last year, they gave them out. As long as it outputs at least 1 amp, it'd be fine. And there are actually people who have calculated how long the Pi will last based on the capacity of those batteries. So I think on the one we got last year, it'd be about 2 hours, depending on what the Pi was doing.
Like I said, a lot of the guides are outdated, but once we kind of got comfortable with the core concepts, we really didn't spend much time on this project at all. It's just kind of we cloned a couple of different Git repos, and we're literally standing on the shoulders of giants here. There's several different example solutions out there, and we've kind of cobbled together some different ones to do our POC. I will say it is very processor intensive. It really needs like a GPU or a cloud solution with that. So that being said, I'm going to do a quick demo. We didn't want to reinvent the wheel. Like I'm not a PhD AI genius. I'm just a guy that wants to count cars and save the city some money. But there's a million other things we could do. We're thinking about. I think AI is going to be the most disruptive technology in a very long time. There's all kinds of legal issues. But the technology's out there and it's in our hands. So this is what one of the solutions looks like. We kind of took a shotgun approach just to see what would work. We got a couple of different examples in Python, and then we have a JavaScript example because it's a lot more browser friendly. And this is all leveraging Google's TensorFlow AI engine. And let's give it a shot here. So I have one solution in Python. It's just gonna.
I can't see.
Oh, I'm going to mirror the display. Don't you love that? So this is a Python solution that reads in a video of cars going down a road. And let's see if we can get this to work. It's going to take a minute to load up. Like I said, it's very processor intensive. And I don't know if you can see that, but it should launch a video screen here in a minute of the traffic video. Oh, thanks. There we go. Yeah. So there's a line there, and that's our delineator to know when to count. Because we were able to identify different things. You'll see there was a white car in the background there. Well, it's saying they're all white cars. but that line is what determines the count. Because if we detect all the cars and count that, it's not going to be an accurate count for what we're trying to find. So this not only does the counting as the cars cross the line, but it detects the movement direction that they're going down, the speed, which is pretty amazing. It detects the color of the car, and then it also detects that it's a car versus a truck or a person or a bicycle.
And it's very easy to change the location of that line. It's just 2 lines in the code on that repo.
For the line, yeah.
Yeah.
Let's see. Here's another Python example. What's that?
An extra E there.
Oh, I can't type. And this example doesn't actually show a video, but if we're lucky, we'll see a log output. And it's capturing all kinds of information in the logs of just what it's detecting. It'll spin up here in a minute. So as these objects in the image that it's importing come in, you're getting all kinds of information. It's getting predictability, percentage probability. Is it 80% chance this is a car versus a bus? It's getting number of cars, number of people. There's 2 traffic lights in this example. And this is actually a different video than what we just saw. And then we tried to do a JavaScript, like an Angular version, because we wanted to put it in the browser, because then we can send it to our friends and our bosses. This might take a minute to start up. So we figured if we could just get a proof of concept that, hey, we can actually count, much less just do the object detection, which is cool on its own. But if we can do unique counts, we could just put this out our window at work and have an effective counter. So again, it's going to take a minute to load up the TensorFlow because it's massive, but considering that it's in a browser is pretty amazing. So the video on the left is the raw video from my webcam, and the video on the right, so that video is streaming to the video on the right that's processing it with the TensorFlow, and it's detecting things. And, oh, there's not a knife. So you get the idea, but the concept here is, we're using different data models as our detection model. So we are using a model called COCO, which is Common Object something.
Yeah.
But it's just a database of common objects. And there's thousands of models out there, and you can create your own models. So if you wanted to train it to identify something that's not very common, you can do that. So this model I'm using now is a very lightweight one, which is probably why I thought my cell phone was a knife. But you get the idea. And we've been testing out different models, and I think our next step would be, or one of our next steps would be to train our own model, just to get the right perspective of where the camera will be, and just to make sure we can do it. With that, I'm going to hand it back to Peter, and we'll see where we left off.
So yeah, our next steps would be to retrain the model to increase accuracy. A lot of times, for the perspective of where you're placing the camera, it may not detect a car. Like when it's up looking out our office window, it's at such an angle, and it's so far from the cars, the model doesn't have like an image of cars like that in there. It's looking for like 20 feet away from the car coming right at you. As you can see in the demo video, it worked really well. But it really depends on where you're putting the camera as to how effective it would be. So the best way to get around that would be to incorporate a way to retrain the model based on where you place the camera, so that in real time it can take those car images, re-import them into the model and retrain it on the fly, something like that. And use that to increase the accuracy so that it does detect cars with higher accuracy. Jim Alberk at Raleigh has a vision for an enterprise video analytics platform that's integrated with ArcGIS. So in this case, we would take like the 100 traffic cameras we have, which are going to increase to many more, and have real-time analysis of those on a map, such that you can click the point on the map, see the video stream, and see a tabular output of the analysis. So how many cars have passed through that intersection in the past day or hour or whatever analytics the person wanted to see. In a situation like that, that's not something we could run on a laptop. So we would want definitely a really heavy server somewhere with a lot of GPUs in it, or that probably wouldn't work either, given that there are 100 cameras out there right now, going to increase. So a cloud solution would really be the only viable option there. And then also Docker containers are probably a much better way to go going forward, just because it is such a nightmare to set up your environment the first time, especially on Windows or the Linux subsystem for Windows. If you do have the option of dual booting into Linux, you'll have a much easier time with just a regular Linux install. Yeah, other than that, Docker is definitely the way to go, and then upload it to AWS or something like that.
And I think this proof of concept, it may never go into production. I mean, we may just do it anyway ourselves, but a good point it made was it kind of helps make the whole smart cities thing real to our management and our department. When I can go into our CIO's office and show him this, and he just kind of gets a feel for what's possible and what's real, that we're behind it, we can do it. And that being said, we've just now got a new position for a smart cities coordinator, and we've got a real budget behind smart cities efforts now. So we want to take all these little fun projects we're doing and kind of combine them together, standardize them, make them real, kind of under that smart cities umbrella. So I just think, even if it doesn't go to production, just for the awareness and the what's possible is really worth the value or worth the effort.
Yeah.
I think that's it.
That's it. Any questions?
Yeah,
sure.
It does, actually. I will show you one quick video. It depends on the model, the database you're bouncing it off against. So if you have a model that has bicycles and cars and trucks, it's going to identify those, and it's pretty accurate. See if I can show this.
Yeah, that's another thing transportation wanted, was count the scooters on the sidewalks for those motorized scooters going down.
Let's see if I can find it.
Any other questions while that's loading? Sure, go ahead.
You guys thought about using crowd estimation?
That'd be real interesting.
It's a great idea.
Yeah, great idea.
Just wanted to make sure you mentioned that it would be able to collect bidirectional data, if it's northbound, southbound, or westbound.
Yeah, that's our goal. Yeah.
Has anybody done this or worked with the TensorFlow? Yeah, it's pretty amazing. And this is just the object detection. It's just a tiny, tiny, tiny slice of the whole TensorFlow world. in AI.
Yeah. Oh, go ahead.
Have you played around with the turn counts?
That's what our traffic department wants.
Yeah.
And I think that would just be a matter of training our own model, where you just provide it a bunch of different cars taking turns. And if for every detection of an object, you need to at least provide 100 images. I think that's what I've heard. So we would need 100 different cars turning and make sure that wherever the camera's placed, it is similar to how the cars were turning in the model that we train it. And training a model is not as hard as it sounds. That's kind of our next step. It's just if you can follow instructions and you're computer savvy, you can do it.
Yeah, you basically just put more images of the kind that you're looking for in the model folder, and then there's like a retrain.py script, and you can run that. And I think it takes about 30 minutes for that to complete. And that's enough right there to start the retraining. Go ahead.
What was your, do you recall like an average storage amount or just like your default attributes that you were collecting?
What do you mean average
storage? So when you were analyzing the video and grabbing like car color, speed, etc.
Yeah.
How much storage did you use?
Oh, that's just outputting to a CSV, so that's really small.
And
yeah.
But that's a good point over time.
Yeah.
Yeah.
Yeah, so
that's
if
true.
you ran it for 24 hours, or an hour, do you know how large that file, how quickly?
Yeah, I don't know.
Well, we could do it where it's not really a file, and it just could stream it to a service in the cloud. Or I think there's some technical workarounds for some of those logistics, but the hard part is getting the people in charge to let us put a camera out on the side, on the corner. The technology is the easy part.
Go ahead.
So, have you pitched this to the mobility and safety at DOT? I asked that because I work for traffic. So all of our accounts that we contract out go through mobility and safety and then hire out.
We've had good response. We have a good relationship with our traffic engineering, traffic operations people, and they seem to embrace it. I don't know if they think of it as a something to like get behind and start pushing for funding and this and that, but there's definitely interest in it. And again, that's where we need help, kind of under that smart cities umbrella with our management and try to make it real.
Well, it sounds like what you're demonstrating, there's a lot less error from factors to it than what we currently use. The contractors, there's simply just as you showed earlier, eyes on counting cars.
Right.
Taking breaks, not starting the stage, things like that.
Yeah.
The method you're demonstrating, you remove all those factors out of the equation.
And I think we could improve it too to make it more accurate. Are we out of time?
You have a minute.
1 minute. All right. I got a couple more questions real quick.
Have you played with any of the builds working on Raspbian, like directly on the pod? I didn't look it up when I was talking. It looks like they have builds set up.
I'm sure it would. That'd be a good way to do it. That's probably worth looking at.
Yeah.
We just kind of picked the default and whatever was quickest and easiest, but I'm definitely down with Raspbian. Yep.
Did it work for the beekeeper?
Not yet.
No, not
But
yet.
if we can count bees,
We need a whole bee model.
yeah, that could be valuable right there.
Yeah.
And so the thing is, the challenge is, what else can we do? I don't know. I have no idea.
We'll ask the DOT.
All right, thanks guys. We're out of time.
Yeah, thank you.